Hi, everybody. For those of you that are way in the back of the room, there's plenty of seats up here. It's not quite the Rolling Stones, but the energy is really great. So if you want to get closer, by all means, come on down. Thank you for the introduction, and we really appreciate being invited here by TU-Automotive to speak about automotive platforms. So it should be a very exciting 20 minutes. My name's Christopher Heiser, CEO of Renovo. We are a company that thinks a lot about what the cars are going to look like, not in the far future, but in the near future. We're headquartered in Silicon Valley. And Silicon Valley is a place that has boundless optimism for what's possible and an almost infinite supply of people that are willing to take hard work and technology and try and solve problems. But until recently, automotive was an area that was overlooked not just by Silicon Valley VCs, but by VCs globally. And the challenges here were an entrenched way of doing business that seemed impossible to disrupt, really, really long payoff times, and an uncertainty of exactly how those payoffs would happen. But since the middle of the 2000s, that's changed. There's a lot of money that's flowing from VCs all over the globe into the space. And that's very exciting because it indicates a real interest in trying to transform the industry. So when we talk about platforms and how we think they're going to change, we get sometimes into kind of cross signals with people that are deep in the automotive space. That what is a platform to someone from a software background is not necessarily the same thing from someone from building cars. And by that we mean that when an OEM or a Tier 1 talks about a platform, they're generally talking about a manufacturing platform. This is something that you use to build several cars under your own brand. They might share suspension components, they might share an electronic parking brake, they might share whole electrical architectures, but the point is that it is a platform for the OEM to produce something. 100% of the design and validation and testing happens before the first car is ever delivered, and this takes years of time and a lot of money to do. And the ultimate focus on these manufacturing platforms is cost efficiency. And it is an extremely good service. Today, OEMs can deliver a fantastic amount of value for a very reasonable amount of money. So when people from our neck of the woods talk about a platform, we're generally talking about a development platform. And that's something that's very different than a manufacturing platform. It enables the manufacturer and third parties to generate value. And there's an ecosystem, there's an arrangement between those two parties to generate the most amount of value. The design spans the breakdown between the pre-production and the post-production. And in many cases, there's more value delivered after the thing has left the factory than before. That's very different. And the critical focus is on open access to the platform and on making the time to market as short as is reasonably possible. So when we think about platforms, we think about creating value on top of something and allowing a lot of people to play in that space. So this is something that we have seen happen over the past 40 years, at least half a dozen times. These are 4 really good examples. That Windows and Intel together created a ubiquitous platform that allowed people to create visual applications. Before those SDKs existed, you had to build your own window managers. It was very, very cumbersome. The creation of that platform unlocked massive creativity on the development side and massive value in the PC space. In the mobile space, you can be an independent developer. You can develop, test, validate, distribute, and monetize, all on top of a platform run by Apple or Google. That's a great example of a development platform and one that allows massive scale. The cloud has evolved to the point where you can write a script in Ruby and deploy it in about 2 minutes on AWS, and you can scale that deployment up to hundreds of thousands of users. You can test your ideas, you can refine your application without ever going into a data center. I did that 20 years ago, and it was really, really hard. And now it's very, very easy. It's a great example of a development platform. And finally, all of us here are part of the social platform. And we're allowing application developers to create value on top of us, of our lives, of our data, on our interpersonal communications. So these are great examples of platforms. A good platform has to be open. You have to get access to it. You have to be able to see the services and data that make up the underlying features of the platform. It has to be robust. By that, we don't just mean safe, but also scalable, modular, and fault-tolerant. Fault-tolerant not just to failures in the system, but fault-tolerant to what the developers will do to the system. Those are two very different things. The automotive industry does the first one extremely well. No one really thinks about the second one yet. It has to be extensible. You have to be able to build things quickly on top of it. And it has to be secure. And that security needs to be built fundamentally into the architecture of the vehicle, or in this case, the platform. So when you look at something like the Lexus, fantastic manufacturing platform, really excellent, really horrible development platform. And the evidence of this is how hard Google had to work to make that work, how much reverse engineering and adding of new motors and rewiring and basically gutting a lot of the electrical architecture of this car to make it do the things they want to do in their system. In fact, they then went on to build their own cars, and now they've done a strategic partnership with Fiat Chrysler to attempt to get better access to the vehicle platform. Today, there does not exist a vehicle platform that allows people to develop on. Maybe if you're inside of the OEM. But again, that's not what we think of as a platform. It has to be open and extensible. And in fact, there are some companies, their entire existence is about hacking these cars to allow researchers, developers, and other people to play with them, to learn, to build applications on top of them. So just as a little aside, that picture of the Lexus was taken about a half mile from my house in Mountain View. You would think that these things driving around would maybe worry people. They would dive out of the way, something like that. This is an email thread that happened last month on the residential email list. And it was the residents of Montaloma suggesting that they liked the Google cars much better than the human drivers. That in fact, they wanted the Google cars to peak their testing at 9 a.m. and 5 p.m. because it would slow traffic down in Montaloma and stop people from cutting through using Waze to kind of get around bad traffic on Alma and Rengstorff. That's really remarkable. So I just thought that was interesting. Anyway, back to, and of course, the thing that they do worse is they are too slow, and so every so often they get pulled over by the police for driving too slowly, but that's fine. So when you think about platforms, you don't talk about what you can't do or what the problems are or what the weaknesses of the existing platform are. You think about the place you want to be. You plan for success. You plan for the biggest scale you can possibly think of, and then maybe times 10 just to be sure. And you try and plan for the unexpected. You try and build a system that's going to be resilient and tolerant of multiple people using it in ways that you may not have fully understood or anticipated when you did your design work. This is what Google and Facebook and Twitter and Apple do well, and they do it at really, really large levels of scale. Let's talk about one piece of these platforms. Let's talk about data. That's a great discussion for telematics. The most important rules about data in platforms is you have to log everything, and the second most important rule is you have to log everything. You never, ever, ever leave anything unlogged because it teaches you about the system, because it allows you to improve it, because it helps you understand the defects. It helps you build faster and better. So let's use an example of a company that does a lot of this. Facebook, for better or for worse. They log everything. So the scale of what they're doing is pretty huge. Around 2 petabytes of data are logged every single day. That's based on over 1 billion active users every single day, 100 billion events, 2 billion media uploads to the platform. When you normalize that down to the user, it's a few megabytes of data stored every single day. This is why Facebook and Google and all the companies are building data centers that store exabytes of data. Exabyte is a technical word for a lot of data. To put that in perspective, 5 exabytes of data would store every single word I've said and the rest of humanity has said ever. So it's a massive amount of data, and these systems are storing maybe as much as that in every year to 2 years. So it's pretty staggering. When you compare that to the automotive market today, the vast majority of the 17 million cars sold in the US in 2015 and the 80-some million sold globally stored 0 data. Some of them stored data locally in an extremely reduced format. So if you took it into the dealership, they could scan it and see if there were any events that were logged. A few companies are logging data, but typically in the kilobytes or tens of kilobytes a day. And then maybe a few companies are a little bit more aggressive. But when you look at the platform companies in the technology space, Google has Google, Waze, Maps, they're buying new companies, they're logging all of that data, and they're learning. Apple's learning every time you use Apple Maps and every time you pick up that device and do something with it. Uber has got a lot of knowledge about what ride sharing and shared vehicles really looks like today. And Tesla is certainly at the leading edge in terms of data. They store gigabytes of data a month. They can log almost everything in the car, and they can get access to that real time. And that can be really useful for them when things go wrong. It allows them to understand why they went wrong really quickly. That's good for the engineers. They also, in some cases, it's good for their PR department because they find out that what the customer said happened maybe didn't happen exactly the way they said. You can imagine what this would be like for a large OEM that was maybe being involved in a controversy about something that happened in their car. That having these abilities to look and see what actually happened on the platform in near real time are incredibly powerful. So examples of this for Tesla are they're learning autonomous faster than anyone else. And they're able to redeploy what they're learning to their fleet faster than anyone else. According to our research, they think they're doing it better than Mobileye. I don't know, but certainly the fact that they log everything all the time gives them the potential to do that. This is where it's going. We as an industry have to figure out how to get gigabytes of data off our cars. That's a requirement because of the complexity of the systems that we're going to be developing and deploying onto these cars. If you can't do this, you're going to be dead in the water. Renovo works on a number of different vehicle platforms. We typically do things that are pretty aggressive, high performance, safety, and extremely tight control loops. What it means for us is that we instrument the cars pretty aggressively. In vehicles like these, hundreds or maybe over 1,000 sensors in a car. What that means is that at any given time, our logging rates are pretty fantastic. We might generate over a gigabyte an hour of data. To put that in context, if the 17 million cars that shipped last year in the US was running Renovo's platform, we would need to store 8.5 times as much data per day as Facebook. Now, we can compress that, we can map reduce it, we can use machine learning on both the vehicle and the cloud to throw out uninteresting data, but it should still get a really clear picture in your head that what we as an industry are doing is we have to do Facebook scale things for cars. And that's really a huge challenge and won't necessarily be solved by any single company alone. So who cares? The answer is all of us, because our products will increasingly be defined by how they evolve post-manufacture. That if we can't do that, the obsolescence curve of what we do will be huge. And that each year, the car that comes out will be so much better than the last one that is going to really change the whole value structure of the market. If you went to the head of internal combustion engines at Volkswagen and you said, congratulations, your technology is going to, the power output of your motor or its efficiency is going to double every 18 months, they would probably think about their development a little bit differently than they do today. But today, the automotive industry is more around 1–2% a year. But that's not the way software works. It's not the way computing works. It's not the way any of these technologies work. So people that can build platforms that teach them what to do, help them solve defects faster, open themselves up to third parties, are going to win in the next round of innovation. So the mobile guys do this really, really well. The shared transportation companies are doing this well. And some automakers are starting to really get serious about this. And that's a positive thing. Another thing to consider about why you want to open these platforms up. There was a betting pool inside of the original iOS team at Apple of how many applications there would be for the iPhone once it became a mature platform. Most people were thinking a few thousand. It's 1.5 million as of last year. Android fans, there's actually more Android apps, so you should be happy about that. But when you think about it, it's 1.5 million applications based on a $600 device with 20 sensors. And the sum total of those sensors is $8 in the bill of materials. I don't know what a sensor costs inside of a Bosch ABS system, but I'm sure it's more than $8. The quality of sensors in the cars, The number of sensors in the cars, the calibration of the sensors in the cars is orders of magnitude better than any mobile platform on the planet. The vehicle is the best IoT platform. And it has no connection, and it has no way to monetize that, and no way for developers to use it. It's absolutely absurd and insane, but it will change, and it will change faster than people think. We think a lot about this space. We try to understand what these platforms will need to be. And like we said before, open, robust, extensible, and secure. That has to be the heart of any serious application for the space. So the things that we do and the things we work on with our partners is trying to bring better computational power to the car. The core engine controller inside of an Audi is about 4,000 DMIPS. The smartphone in your pocket is about 30,000. Your PC is around 100,000. And the devices that are running autonomous cars today are tens of PCs in terms of their capability. So the computational capability and the vehicle network capability is not taking CAN bus and adding one more or taking another embedded controller, adding two more. It's totally different. The architecture is different. And you'll see lots of tier ones and tier twos here today showing their visions of what that platform will look like. That platform requires a lot of software and a lot of cloud services to make it valuable, both to the OEM and the third parties. Telecommunications infrastructure, $10 to $15 a gigabyte is not a way to effectively manage a telematics empire. So we love all the carriers, but they and the rest of us have to figure out a way to get a lot more data off these cars for a lot less money. That's something that the big guys on the internet side and the mobile side have figured out. We have to figure it out for cars. And then finally, software environments. And again, it's about making these extensible up, bringing lots of parties, creating environments where many, many players can invest, test, learn, and ultimately commercialize. But it definitely has to start with great conversations with OEMs to make platforms that enable this. Change can happen a lot faster than you think. Nokia, in 2007, the top 6 phones in the world were Nokia, over 100 million of them. In the same year, Apple launched a phone that, by the way, was 10 times faster than the Nokia 6500. It was over-provisioned. That was a really important thing that they did. They over-provisioned its capability. And within 5 years, about one automotive cycle, it was exactly the opposite. 140 million phones for Apple, and Nokia didn't have any phones in the top 10. And the speed and the capability of these platforms, and this is true of the Android platforms as well, are massively increasing over time. And something that you bought even 2 or 3 years ago is perhaps 10 times slower than what you bought. So that's the type of technology that's going to drive autonomous, connected, electric, shared vehicles. I was at an event a couple days ago, actually a week ago, and there was a young entrepreneur who excitedly shared with me that he had built his entire autonomous driving system in Python. I don't know if there are any embedded programmers in the audience, but that probably freaks you out. Python's a scripting language. And my thought when I heard him say this is, that is never going to work. That is the craziest thing I've ever heard. But when C was the language of choice, they didn't say C++ would ever be performant enough to do anything. It basically owned visual computing. When Java came along, the C++ guy said, that's never going to scale. You can't take an interpreted byte compiled language and make it work. It owned the core of the internet for about 5 or 10 years because of the frameworks they built on top of it. Those guys poo-pooed PHP and Python. Guess what? Python runs a lot of Google today, and PHP runs the vast majority of Facebook. The tools will be rejected by people who are unfamiliar with them, but technology has a way of taking the tools that innovative people want to use and making them robust and scalable. That's going to happen. So when you see people that are espousing something that seems crazy, you shouldn't reject it out of hand. Try and find out what's there. Try and dig a little bit deeper. That's the Silicon Valley attitude. There's a lot of effort and excitement in my neck of the woods about what's happening in automotive, and you're going to see a lot more technology and a lot more leadership, but it's going to come in partnership with tier ones, tier twos, service providers, telecommunications. It will be a consortium that makes this happen, and we're here today to say hello and say we'd love to talk to you. And finally, I just want to end it with one of my favorite characters, Blake, from Glengarry Glen Ross. For us, development is a way of life. You build platforms because you're always going to be developing, always be developing. That's how we think about it. That's how people in Silicon Valley think about it. This sort of thinking is not, I think, consistent with where automotive is today. That will change, and it's going to change pretty quickly, and we're excited to be a part of that discussion. And thank you for your time today.